So we're starting quadratics. This will span over the next 4 lessons. It also kicks off our very last unit, which is super cool. So we have quadratic equations, which is an equation whose highest exponent is 2. So most of our class so far has been dealing with linear equations whose highest exponent is 1. They make nice straight lines, but these ones are going to involve a lot of x squareds going on. So it's going to change the way our graphs look a little bit. In fact, our graphs are now called parabolas. Seems kind of weird. These are those U-shaped graphs that we look at, and we're just kind of making them more formal and giving them a name now. So they can open up so that they look like a U, or they can flip kind of upside down, and they'll go this direction instead. Kind of look more like a mountain. If you're looking at the first kind, it means that your equation involves a positive x squared term. Now it could look like 3x squared, it could look like plain x squared, but ultimately that term is going to be positive. If your graph is flipped over, it means that somewhere in there your x squared term is negative. Now it could be plain negative x squared, but it could also mean like negative 5x squared or something like that. Now, the answers to quadratics can be called a lot of different things. In fact, there are 5 things. Solutions, the first one, is kind of the most generic, and it works for really any method that we're going to have. We're going to end up with 4 methods, and if it asks for solutions, it's really pretty general. X-intercepts kind of give you more of a direction, and we've been working with these for a really long time in our class. This is where we were looking for where our graph crosses the x-axis. And they could be a coordinate that looks like a number, comma 0, and that number is the one that we're going to be looking for. So really, this is pretty similar to some of the things that you already know. Zeros we also took a look at, and it was the same kind of deal. We were looking for the x-axis, and we were looking for where the number makes your equation equal 0. So it was the same kind of thing as an x-intercept. Now we are going to add a couple totally new things like roots, so we're going to end up using those square roots again to try to get that x alone. And then factors, which is going to connect back to our factoring section. You're going to see something that looks kind of like this. That's where that comes into play and why we needed to do that. All right, you'll end up using this method a lot in Algebra 2. For now, we're going to end up touching on all of them, but for today, we're just going to do solving quadratics by graphing. It's by far the easiest method, and I'm sure you're really going to like this one. Now, when it comes to solving, the words that kind of can tip you off to use this method would be your generic solutions. That one works for any method, but x-intercepts, it kind of implies that you need to look at the x-axis, or same thing with zeros. Now, when you're solving quadratics, you have 3 options for the number of solutions that you can have. So the first option and the most common is to have 2 solutions. If you think about that U-shaped graph, it is going to whip around and cross that axis typically twice. So one here and one here. So your job would be to write down whatever this number is and whatever this number is. All right, another option is to have 1 solution. Okay, that would be where your graph comes down and just kind of bounces off the x-axis and then continues on its merry way, so that either the bottom of the U or the top of the mountain, because these could be negative as well, would be your single solution. It is also possible to have no solution whatsoever. And that would be if your graph kind of floats either above or below the x-axis. Okay, yes, it does cross the y-axis, but we're not looking for y-intercepts here. This is only x, only x. All right, in order to make this work, we're going to end up using Desmos. So your job is to type the full equation into Desmos. Now, in Algebra 2, you start graphing these by hand and looking at different properties of them. But here in Algebra 1, our job is to just graph them and figure out those x-intercepts where it crosses the x-axis. So that's our next step, is to determine where the graph does that. All right, so I have Desmos already pulled up here on my iPad, and I've kind of pre-typed in all of our examples, so that way it just saves some time. So I'm going to go ahead and slide this over, so that way you can see the example and the graph here at the same time. There we go. All right? So on the first one, we want to type this whole equation into Desmos. Now you'll notice I have that graph pulled up on the screen. That's the example that we're working with right here. And I haven't quite finished typing it in. I still have to put the equal 0. If you skip the equal 0, it does give you that nice parabola shape. We have a positive x squared, so it's opening up like a big U. And ultimately, I'm looking for where it crosses the x-axis. So that would be here and here, and you can click on those gray dots. And it's very clear what our answers are going to be, -6 and -4. Now, if I change this to actually type in the full equation with the equal 0, instead it puts vertical lines on my graph instead of that U shape, which still give me the same answers of -6 and -4. It's just because it's graphing the solutions. So that would be x equals -6, a vertical line, and x equals -4, a vertical line. So when it comes to writing down our answers, here's what this can look like. Okay, we can write down something as simple as x equals -4 and -6, kind of like that with a comma. You can split those apart. Here's another option. So x equals -4 and x equals -6, you can split them apart. You can copy down these coordinates directly, -6, 0, and -4, 0. Okay, now notice that both of these are x's, so I can't put -6 and -4 together in the same set of coordinates. That doesn't work so good. You're going to see this a lot on the assignment that goes with this, is a set. So remember, in a set, order doesn't matter. You just have those squiggly braces, and that's good. Yeah, I know you guys like squiggles. All right, so your last option is to just write them plain out, -6 and -4. Order doesn't matter, so I can put the -4 first. -6 could come first. Either one is okay, as long as you list both. That's the important part. All right, moving to our next example. Slide this over a little bit this way. We have x squared minus x equals 2. Now, if you were trying to graph this by hand or something like that, you would need to make sure that this equals 0 first. But because we're using Desmos, we don't have to worry about that so much. And here's that graph. Now, I already have the equals 2, and with that equaling a number, it is going to put the vertical lines instead of the parabola on there. So it looks like I have -1 and 2. I'm going to go ahead and write this as a set on this one. And that's it. It's super great. All right, since I can see this one here, we're going to go ahead and do that one too. All right, so I'm going to go ahead and take that off and put this one on. Again, we have those nice vertical lines instead of the parabola. So we have 2 and 4. I'm going to go x equals 2 and x equals 4. Again, the format of your answer doesn't really matter. You can choose any of those. They all meant the same thing. This is the way I typically write it if I'm solving problems, but it's common to see the sets as well. I'm going to shift my paper back so that way we can check these out. Now, if they say y equals, that's really okay too. It just means you're going to actually see the parabola instead of those vertical lines. So we'll take this guy out and turn this guy on. Okay, now you'll notice on this one, here's our x-axis down here, and my graph doesn't cross the x-axis. So because it doesn't cross the x-axis, there's no x, this one is no solution. All right, moving on to the next one. Now this one's a little bit different. It does have that negative going on there. I have a nice parabola. Here, if you're not sure where it crosses, because it looks like this one's in the middle, we have 0, 0. So 0 is allowed to be an answer. That's okay. And then I have -2.5. So it is okay to have decimals and fractions as answers. So I could say that this is -2.5, 0, kind of like that, as both x values. You could write them as coordinates. Now, some people prefer the fractions, so I went ahead and typed in -2.5 here. And if I go ahead and hit that little fraction toggle, it can turn it to -5/2. So this is okay, or you can go ahead and change that so that it looks like -5/2 and 0. Cool. All right, so we have one more. Pick this up a little bit so people can slide under. All right, and that'll give me x squared plus 4x plus 4. All right, so we'll turn that guy off, turn this one on. All right, you see that nice parabola shape? It looks like this is one that just kind of comes and bounces off the x-axis. So I'm looking for this bottom point right here. We ignore y, no y. And then it doesn't touch a second time. That's it. So we have -2 as our final answer. So I'm just going to put x equals -2, and that's solving quadratics by graphing.